Okay, guys, so this is chapter 20. I only want you to print out pages 1 through 9 in the notes, because this is really what you'll need for the AP exam as far as note-wise and practice problems. And so print this out. We're going to go through several of these examples. They're going to be very similar to equilibrium, chapter 18. But there's a few just things that you can tweak along the way. Okay, so I'm just going to read through this real quick. So far we've discussed substances that are rather quite soluble. So we've talked about acids, we've talked about other substances such as like salt, things with sodium or nitrate, other soluble things, okay? Although most compounds dissolve in water to some extent, many are so slightly soluble that they are called insoluble. And so you will want to review your solubility rules from chapter 6 and get very familiar with them as we're going forward in this unit. So the dissolution of a salt is a reversible process. So dissolution, what that means is dissolving. So when a salt dissolves, and we're not just referring to table salt, when a salt dissolves in water, such as, let's use table salt, NaCl, okay, it can go back to that solid state whenever the water dries up. Okay, you've probably seen that little experiment in middle school or elementary where you leave a cup of salt water out all day long, water evaporates, by the end of the day you have the white crystals at the bottom. Okay, so dissolution of salt is a reversible process that can be influenced by environmental factors such as pH or other dissolved ions. As a rule of thumb, those compounds that dissolve in water to an extent of 0.02 molar or more are classified as soluble. Okay, silver chloride is rather insoluble, meaning that it doesn't really dissolve in water, or at least it dissolves less than that amount. Careful experiments show that if solid AgCl is placed in pure water and vigorously stirred, a small amount of AgCl dissolves. So what we can do here is we can actually use that knowledge and talk about what's called the solubility product constant. So the equilibrium constant expression for this dissolution is called a solubility product, KSP. The dissolution of a salt is a reversible process where we can describe that by KSP. Okay, so determination of this. Let's talk about the nitty-gritty. The solubility product constant, KSP, for a compound is the product of the concentrations of the constituent ions, each raised to the power that corresponds to the number of ions in one formula unit of the compound. Okay, so we're going to do several examples here. Consider the dissolution of silver sulfide. Okay, the solubility product expression for Ag2 is, now here's the reaction. You can see that Ag, there's 2 Ag plus ions for every 1 S2 minus ions. Okay, the coefficient in front. The KSP, we're going to multiply the concentration of the ions involved raised to their power. You can see that the solid starting substance is not in the KSP. It is only the ions that are produced. Now this value, okay, is typically going to be given to you, and we'll talk a lot about this, but the smaller the number, okay, the smaller the exponent, the less it dissolves. Okay, so this one's a pretty small number. Very, very, very small amount actually dissolves. Okay, the concentration of the solid is never included in the equilibrium constant. Okay, so let's practice this. Write the dissolution of solid calcium phosphate in water. Okay, and we can go ahead and write the KSP as well. So let me zoom in here. Okay, so we know that calcium phosphate is Ca3PO4 2. Okay, and that would be a solid. when it dissolves, if you think about your solubility rules, okay, we place it in water. You can either put water in the expression or not. It's up to you. I'm going to leave it out. It's going to produce 3 Ca ions. Okay. For every 2 PO4s. Now remember, this is one that dissolves slightly, okay, very slightly soluble. So if we were to write a KSP for this, okay, we're going to include Ca2 plus raised to the power of 3, phosphate ion raised to the power of 2. Now in the back of your book, okay, in the appendix, you can find the KSP value for this, and it would be 1.0 times 10 to the negative 25. It's in one of the appendixes. Okay, now I'm going to stop the video here, and we'll start our next video with example 2021, or 20.